Okay, derivative dy over dx at x equals to 8. Derivative of y with respect to the variable x at point A. So this is going to be a number. Okay, this is at a specific point, so that's going to be a number. That's going to be a number. These are functions. These are like formulas. Here is another symbol, f prime at A. So these are very specific. All right. All of these, once again, mean the same thing. Okay, so f prime is the derivative of function f. That's the same as saying y prime, which is the derivative of function y, which is the same as saying dy over dx. Okay, the derivative of y with respect to x, and that's the same as saying d f over dx. Okay, sometimes again you might see it something like, you might see the notation being something like this, but all of these means the same thing. So whenever you encounter either one of these symbols, know that they mean derivative function. Okay, so now we have gotten past the symbol. Let's go ahead and look at how we find the derivative function. But let's go ahead and review how we find the derivative at a point first. Okay. From lesson 3.1, remember that the derivative at point A, there are two formulas for us to find the derivative at point A, but the most popular one is this guy. Okay, that's how you find the derivative at point A. So, by reading the problem, I want to find the derivative at x equals to 4 of this function. Step 1, I want you to determine that a value. Where is the location of the derivative? Well, they want the derivative at 4, so a equals to 4. Okay, we're going to use this formula to find the value, to find the slope at 4. But before we start plugging things in, we need to find out what is f at 4, because a is 4. So in step 2, why don't we do that first? We find f at 4. Okay. And all you have to do is plug 4 in here. So plug 4 in there. That becomes 16 minus 3, and that's 13. We also need to plug 4 plus h. We also need to find what that expression equals to, or that function value equals to. So go ahead and part of step 2, let's go ahead and also find 4 plus h. 4 plus h. F of 4 plus h. Go to your function f. Replace the letter x by 4 plus h. So 4 plus h. Okay. Go ahead and expand this, and if you did it correctly, you're going to get 16 plus 8, h plus h squared minus 3. Subtract 13 plus 8h plus h squared. Okay. So step 1 and step 2, find these values. Step 3, go ahead and plug them into the formula, to the derivative formula. So step 3, here's how I like to begin step 3. Start by writing f prime at 4 is equal to the limit, and then just go ahead and write its symbol so that you know exactly what you're doing. Okay, and now it is time for us to plug those in. So we know that f prime at 4 is equal to the limit at h runs to 0. This is 13 plus 8h plus h squared. So 13 plus 8h plus h squared minus f at 4. F at 4 is 13. Okay, over h. Now if you look carefully, the 13, they're going to cancel out. 13s are going to cancel out. We are left with 8h plus h squared, and that allows us to factor out an h. Okay, and these will also cancel out. Okay, if you can't see that, take your time and make sure you see that. Notice that these two guys contain an h. I can factor that h out, cancel it out. Now I'm almost done, so make sure you take your time and write the notation clearly. The derivative at 4 is the limit as h runs to 0. of 8 plus h over 1, because we cancel that out already, and as you plug 0 in, then you just get 8. So guess what? The slope at 4 is equal to 8. Alright, that's how we find the derivative at a point. Now let's go ahead and find the derivative function for the same function. Okay, for the same original function. So find the derivative function. Now, when you find the derivative function, you don't have step 1. You're not looking for the derivative at a specific point. So you don't have step 1. You just directly go on to step 2. Okay? So in step 2, and I'm just going to call step 2 our first step. So our first step is just to write this down. Write down the function. Okay? And then also write down the function, if that's x, okay, then our second function is called as x plus h, f of x plus h. Okay, so f of x plus h, because we're just generalizing this formula. We don't want to plug in a specific number. We just want to plug in x there. Okay, so f of x, and then f of x plus h. Remember that? This is the derivative function. The derivative function is the limit of f of x plus h minus f of x. Okay, and that's why I'm using the letter x, because of this definition of the derivative function. So the cool thing is f of x is always given to you. All you have to do is find f of x plus h. So replace the letter x by x plus h. So x plus h squared minus 3. And then you have to do some work for this problem. If you FOIL, you're going to get x squared plus 2xh plus h squared minus 3. Alright? So we do this, and then in step 2, we go ahead and we write down the definition of derivative function. Okay? So the derivative function is the limit as h goes to 0 of f of x plus h minus f of x over h, and then we plug it in, and then we plug those in. I am looking for my highlighter so I can keep things a bit more neat and clear for you. Alright, so step 3, draw a little bar over here. Go on to step 3. We are going to plug our values in step 1 into step 2. Okay, so step 3, the derivative function is the limit as h runs to 0. Okay, now this will be plugged in here, which are these. Okay, and then remember that there's a minus sign right there. See how there's a minus sign right there? There's a minus sign right there. So I take that expression and I replace it for f of x plus h. So that's x squared plus 2xh plus h squared minus 3. Don't forget that. Okay, and then minus, and then f of x. Now f of x is right here, guys. F of x is x squared minus 3. But you need to include, you need to put parentheses around these terms, because to remind you to distribute this minus sign. Otherwise, if you don't, you're going to make a mistake. Okay, so there you have it. And now things are going to clean up really nicely. Notice that this is going to be like a minus x squared plus 3 once you distribute the minus sign. So they will cancel out. This and that will also cancel out. See? What do you have left? You got this left. 2xh plus h squared. Okay. Fact out the h and then cancel that out with the h at the bottom. You're left with this. You're going to be left with 2x plus h. Okay, so f prime equals to 2x plus h. As h runs to 0, we know that f prime equals to 2x. So this is a function. It's a formula that allows you to find the derivative at any points. So remember earlier, if we want to find the derivative at 4, just plug 4 in there and you get 8. Okay, so it's pretty cool. It's a formula, it's a function that allows you to find the derivative at any point. If you wanted to find the derivative at the point x equals to 3, you plug 3 in there and you get 6. So you don't have to go through all these hard work to find the slope at x equals to 3. You can just plug that in here once you have developed the function. Okay. All right. Let's do another one. Let's do this problem quickly. So I want to find the derivative function. Step 1, I will write down the function and also x plus h. Okay. Replace x by x plus h, square it plus 1. Simplify this, expand that. Okay, so that's step 1. Step 2. Step 2 is to write down the formula. Okay, the derivative function is the limit as h runs to 0 of f of x plus h minus f of x over h. Okay. If you need to, write this formula a few times so that you memorize it. Step 3 is to just plug them in. Step 3 is to plug, remember, you're keeping this notation the same. Okay. You are plugging in, what are you plugging in? Well, you're plugging the value for this in, which is that, so that will go before the minus sign, right? Very important. So x squared plus 2xh plus h squared plus 1. Don't forget that minus f of x. F of x is x squared plus 1. So you have x squared plus 1, like that, over h. Distribute the minus sign. And if you distribute the minus sign, you're going to get negative x squared minus 1. Things are going to cancel out. So like this one will go away. These guys will go away, as you can see. So what do you have left? You got something that looks like this. 2xh plus h squared over h, right? You now factor out an h in the numerator so that you can remove that with the h from the bottom. It makes it a lot easier to take the derivative. Like that, they go away. What are you left with? 2x. Good. F of prime of x is equal to 2x. Okay. So guess what? Example 2 and 3, they have the same derivative function. Okay. What does that mean? Well, this constant after the x squared does not affect the slope of the graph. The only thing that these numbers do to the graph, it shifts the graph either up or down. So how can that change the derivative, right? Kind of makes sense. Okay. Now, it is not always easy to find the derivative function. Okay, like for example, if I want to find the derivative function for this function, it would be really hard for me to simplify to get past step number 3. So sometimes all you have to do is set up the limit definition for the derivative and you leave it alone. So let's do that. Step 1. This is my original function. And I'm going to plug in an x plus h. So you replace all the x's by x plus h. Okay. Step 2. You write down the derivative function or the definition of the derivative. Like that. And then in step 3, you plug those in. So step number 3, you plug those in. But you gotta be careful because f of x plus h is this whole thing. So you have to replace that in for, sorry guys, I didn't give you guys time to copy that down. So pause the video, copy those down. Take that and plug it in there. Okay? This is f of x. f of x plus h means you replace x by x plus h. X gets replaced with x plus h. So step 3, we plug it in. So then we get something like this. Remember, this goes before the minus sign. This is f of x plus h, which is this guy. So put that in there, x plus h minus x plus h cube. Sorry about that, that's cube. Minus, and then just this guy, rad x minus x cube. Put that in the parentheses over h, and you're done. That's all they ask you to do. Just set it up. Don't simplify it. Don't go any further, because it is nearly impossible to go any further. Awesome. What's the next part? And then we'll continue on the back side.